Welcome to AI for Good. Today, I am delighted to be joined by Dr. Myung-Jun Kim, the president of ETRI, South Korea's National AI Research Institute. Dr. Kim, artificial intelligence, AI, is drawing attention as a breakthrough technology to overcome ICT limitations. So what are South Korea's or ETRI's AI policies or strategies that cover industrial innovation, jobs and social development?
The ICT industry has been leading national economic growth worldwide. And in the 2020s, we need to prepare for the AI era to unlock the ICT growth potential. ETRI is pushing to strengthen R&D on artificial intelligence under the slogan, building on XPRIZE AI innovation platform for realization of intelligence in Korea by developing the ETRI AI strategy in 2020. ETRI is looking at AI technologies as implementation of human intelligence with computers, AI services that create new values in various application domains, and AI paradigms that generate innovations in all areas, including lifestyles, industrial structures, jobs, and government policies.
So what are ETRI's efforts to develop intelligence convergence technologies in economic, social, and industrial systems close to the general public?
Nowadays, the worldwide demand for ICT-based intelligence innovation in all industrial sectors is increasing in response to the fourth industrial revolution, which reshaped the national economic, social, and industrial system. South Korea aims to lead digital transition with the Digital New Deal to overcome the nationwide emergency triggered by the COVID-19. It is thus necessary to promote optimized intelligence solutions at the national and the social system level to evolve from conventional information connectivity and processing efficiency among existing industries such as defense, safety, medical, manufacturing, administration, urban transportation, energy, environment, agriculture, and fisheries. ETRI is seeking to develop an intelligence convergence platform that systematically links core technologies required to enhance the productivity of Korean industries, foster new future industries, and improve the quality of people's lives. ETRI provides key technologies in converting the existing connectivities-based ICT infrastructures into national economic and social system based on high trust and intelligence.
The importance of developing and spreading innovative intelligence information standards in various industries is growing through AI technology. So how should ITU and other international standards organizations respond to this new paradigm?
As the importance of artificial intelligence is being highlighted, South Korea, the United States, and other countries are announcing strategies for foster the artificial intelligence industry at the national level and are working in standardization organization according to these strategies. Since the standardization for artificial intelligence is still in its early stages, standards development organizations have led the foundation for developing standards by proactively securing the standardization agenda and establishing new study groups. As a result, a number of standards are being developed in various fields. The AI standardization efforts of ITUT, for example, are carried out at SG13, SG16, SG17, SG20, and they can be categorized into two perspectives: developing AI technology standards, incorporating AI technology into existing technologies to make them more intelligent. ITUT should consider both perspectives, and I believe they are doing a great job. In addition, I need to consider the safety and ethical aspect of AI systems, since the standardization for the safety and ethical aspect of AI systems are carried out, such as at the JTC1, SC42, and the IEEE. It is necessary to cooperate with other standardization bodies. In this regard, ETRI has co-founded the MAPI, Moving Picture Audio and Data Coding by AI, an emerging de facto standard developing organization to develop standards required by industry. In conclusion, while many different standards are being developed, it is essential to coordinate and collaborate with various ITUT research groups, international standards organization, and other related groups to prevent work duplication and provide standards on time.
Well, thank you very much, Dr. Kim, for sharing ETRI's vision on artificial intelligence, and thank you all for watching.
Hello everyone, my name is Hyungjun Kim, today's moderator for the ETRI special session at this AI for Good Global Summit 2021. I'm very glad to chair this technical session for 90 minutes with 5 speakers who all work for ETRI. Each speaker will deliver a short presentation of 15 minutes. Now I would like to introduce the first speaker. I believe that you've heard about the term singularity. Yes, Ray Kurzweil reserved the term singularity to describe the day when there will be no distinction between humans and machines due to a rapid increase in AI. As his initial predicted date, 2045, is now brought forward to 2035. Nobody can guarantee the singularity, the time when AI surpasses human beings, will arrive much earlier than the year 2035. Nevertheless, ETRI has established the ETRI Technology Development Map 2035 to set the R&D direction for the year 2035. This presentation is what ETRI thinks about how the future will become. Dr. Seung-Hwan Lee, who is in charge of technology planning, strategy section, will guide you a future world of 2035 created by ETRI with 2 short videos. Please enjoy this presentation.
Thank you, Mr. Chairman, for introducing me and my topic of today. Hi, I'm Seung-Hwan Lee. As a director, I'm in charge of making ETRI's Technology Development Roadmap 2035. My talk is about the future world of 2035 created by ETRI. Here we have the content of my presentation. After giving you background information, I'll talk about some examples of future forecast. Then, a creative thinking experiment and its result, new conceptual forms, will be followed. I will conclude my talk by introducing ETRI's 2035 in brief. What is the future? The dictionary meaning of the future is the time that will come after the present. It is impossible for humans to accurately predict the future because foreknowledge is the area of God. Professor Jim Dater is a pioneer in future studies. In 1967, she created the Future Association with Alvin Toffler. According to Professor Dater, future studies is not about predicting one future, but about predicting multiple alternative ones. Peter Drucker is the father of modern business administration. The future is very important in decision making. This is because the more uncertain the future, the more difficult making decisions. Drucker said the best way to predict the future is to create it. Putting together the concept of those two experts, we can think that the future may not be one but many, and we can make it as we wish. Painter Jung-moon Lee is a representative cartoonist who imagines the future in Korea. He imagined a life of 2000 in 1965. That is the picture on the left. For example, a small TV phone has different names, but it is the same as today's smartphone. Most imaginations have been realized now. The picture on the right shows how he imagined. For example, the small TV phone drew hints from radios used by soldiers. It is not just to imagine anything that didn't exist at the time. It is the result of adding a prediction of technological development to the fact of 1965. Most of his imagination has been realized, but the school trip to the moon is not. Why? In the middle of the presentation, I will tell you why. The future is uncertain. In other words, it means that everything will be possible. It is a possible future. However, considering the probability, the probable future will have fewer branches than the possible future. It may be a possible future for the sun to rise in the west, but it doesn't look like a probable future. So, if we let the future go as it flows, we will have the most probable future, whether that future is what we want or not. Would that be desirable? If we can change the future with our effort, how about we create our preferred future? From now on, let's look at some future forecasts from the viewpoint of the form they have been realized. The picture on the left is a collection of 2000 at the 1900 World Expo in Paris. You can see video conference, cleaning robot, flying mailers, and so on. Amazingly, most of their concepts have been realized now, apart from their forms. The concept of the video conference is the same. Indeed, its realized form is similar with that we have at present. However, a cleaning robot imagined in 1900 has the same concept, but a different form compared to the current one. Shall we look at other cases? Various organizations are predicting different futures through visualized forms. Painter Jung-moon Lee is still actively predicting the future like 2041, 2050. Samsung introduced its future vision, Samsung KX50, in 2019. it is about a life after 50 years from now. The future shown in the previous slide are not all completely different. There are common concepts such as AI robot, brainwave helmet, and so on. However, the form and the timeline of realization are different each other. Why did they predict the timeline differently? And why the painter Jung-moon Lee's school trip to the moon mentioned before does not come true yet? The answer lies in technology. Technological development has certain laws like Moore's law. The same goes for not only the ICT field, but also the non-ICT field. In addition, since there is innovation that breaks such laws, it is very difficult, even for experts, to accurately predict this. Painter Jung-moon Lee predicted the future based on current facts at the time, but there was no accurate information on the reduction in space launch cost. The cost is still very expensive, so that students cannot afford to pay the space trip cost yet. ETRI conducted a creative thinking experiment for making the roadmap. The roadmap consists of new conceptual forms and their core technologies based on the R&R. The new conceptual form is a future service or product that does not exist at present. The form is made reflecting not only the technological advancement, but also the requirement for national intelligentization. It is a conceptual design necessary for a first mover who takes the lead in the future that no one has been to. On the other hand, fast followers don't need to create the future because they only have to follow those who are currently ahead. ETRI's vision of 2035, a preferred future, is X plus AI. The definition of X plus AI is an intelligentization of every domain X of the nation as a whole. There are 4 sectors for national intelligentization: individuals, society, industries, and public services. The national intelligentization will change the core values. The core value in the past was growth. However, that for the future will be humanity. For this, the role of ICT expands not only to industrial development, but also to the quality of life, community happiness, and life and safety first. ETRI has newly defined technological and social roles to establish a future vision of 2035. This slide shows the technological role of ETRI. It is to lead the infrastructure 4.0 technology that converges the physical and cyber world on a convergence platform. Looking back on the development history of Korea, every 30 years, the Korean government built an infrastructure in advance, and afterwards, the private sector blossomed based on it. In the 1970s, the physical infrastructure, the road network, was built, and the manufacturing industry grew. In the 2000s, the communication network or cyber infrastructure was built, and the ICT industry grew. Likewise, in 2030s, the convergence platform will be built, and the national intelligentization will be realized on that platform. The social role is to realize the core value of national intelligentization, humanity, using human-oriented ICT. We derive social roles from comprehensive and macroscopic perspectives based on analysis of national plans and strategies. Human-centered ICT for individuals, appropriate ICT for society, disruptive ICT for industry, and sustainable ICT for public services are derived for the national intelligentization. This slide shows 12 new conceptual forms derived for the ETRI's technology development roadmap, considering both technological and social roles. For individuals, we have digital personal assistant, life companion robot, and connected mobility. For society, augmented body exoskin and affective care are derived. For industry, we have smart farm, AI tutor, autonomous factory, and medical AI hub. For public services, we have AI military staff, energy maestro, and digital twin city. I will conclude my talk by introducing one day in 2035, where these new conceptual forms are harmonized in our daily life. You will see two videos in sequence. The first episode is about individuals and society. The second one is about industries and public services. Thank you.
Let us glance at a day in the future, a day in 2035, which will be created by ETRI. Another busy day in the city begins. The infrastructure of the digital twin city optimally balances and maintains its complex operations and status, facilitating a foundation for a safe and convenient life. As our life expectancy increases due to the advancement in medicine, we will be physically fit, thereby leading a happier life. The exoskin, a neuroprosthetics connected to our brain and nerves, protects our body from any accident that might occur in everyday life. If your children encounter a dangerous situation while you are working, you can count on a digital personal assistant to take care of and comfort them on your behalf. Like a genie in the lamp, your digital personal assistant will be there for you when you need it, thus helping you handle daily chores and complex tasks at work. You do not have a driver's license? Don't worry. Artificial intelligence, AI, will drive for people in 2035. You can focus on what you need or want to do during the day while traveling without worrying about car or road accidents. Now, cars have become more than just a means of transportation. Once you get into your car, a personalized smart space made by augmented or virtual reality and three-dimensional hologram will appear. Emotional content that suits your daily physical and emotional needs will be provided and help your mind and body recover. When the boundary between the real and virtual worlds disappears, you can learn from wherever and go on a virtual field trip whenever you want. Wouldn't it be wonderful to have a robot that would perform domestic chores for you? Plan a dinner with your parents today. Thanks to your companion robots, you can now fully enjoy your parents' company.
Let us glance at a day in the future, a day in 2035, which will be created by ETRI. Another busy day in the city begins. The apple mango becomes popular these days, so the farm is very busy in growing them now. Here, another order has come in. The AI controls the environmental conditions of the farm to increase the production volume to accommodate the new order. Smart Farm protects crops from various pests and diseases. It also responds to sudden climate changes autonomously for producing the best crops that are always tasty. The autonomous factory receives the order of various apple mango products from the Smart Farm. It quickly sets up a customized process from manufacturing to packaging, according to the type of products. It operates smoothly and autonomously. In addition, the autonomous factory is able to design and make products upon customer requirements without human intervention. It maximizes the efficiency by simultaneously manufacturing multiple kinds of products in the same facility. In 2035, Energy Maestro produces and trades eco-friendly energy autonomously by predicting the energy supply and demand of a city. Hence, the city becomes energy independent and the carbon neutrality will be achieved. Today, the smart farmer visits his son, who works for the military. The farmer made an appointment in advance. However, it seems that the military operations meeting is getting longer. The AI military staff is a great advisor. It helps military commanders build strategy and tactics, so that the commanders improve their combat power with military simulations, and respond quickly to emergency situations. When the farmer meets his son, his parent is getting medical treatment in hospital. Is the farmer worried about not being able to be with her? I don't think so. The farmer can attend his mother's treatment site online, easily, if he wants. Now, his mother is getting treatment from AI doctors around the world, through the global AI collaboration system, called Medical AI Hub. The Medical AI Hub analyzes similar cases, and clinical results scattered worldwide, to find the best treatment for his mother. The developments in information and communications technology will facilitate a more convenient and happier life.
Welcome back to this ETRI special session. Now I'd like to introduce the second speaker. Have you ever imagined the drone delivering everything you need? After listening to this presentation by Dr. Jung, you may believe that the future is not so far away. Dr. Hoon Jung developed a drone safety control and real-time multi-drone control technology to ensure 100% reliability for safe drone delivery at ETRI. He will introduce the background and the requirement of drone delivery services, focusing on major domestic and foreign logistics service providers. He will then explain the drone delivery system implemented in the year 2016, the current development project, and the future development direction. Please enjoy his presentation. Thank you.
My name is Hoon Jung at ETRI. I'm in charge of drone delivery research and development as head of the Postal Logistics Technology Research Center. Under the title, Current Status of Untact Last Mile Delivery Technology and Service Using Drone, I'd like to focus my presentation on the latest drone-based delivery service trend and outstanding technology development project around the world. Before dwelling on the drone delivery technologies and service trend, I'd like to begin with a brief overview of drone-based delivery services. Next, I'd like to talk about what kind of drone delivery research projects are being carried out globally. At the end of my presentation, I will introduce you to the effort to build future-oriented drone delivery systems, expected effect, and implementation schedules. A drone delivery service can be defined as a service that delivers any type of cargo desired by consumers through a drone-based delivery system at the desired time to the designated place in the fastest and the most accurate manner possible. Behind our strong drive for innovations in drone technologies is the nation's desire to realize a universal delivery service for every corner of the country. We are also required to cut down on the country's shipping cost, accounting for more than 50% of its total logistics cost. In the venture, we also see an opportunity to create a new logistics market centered on drone services, bring innovation in the logistics industry, and generate sizable profits in the process. Before embarking on developing drone delivery technologies, we conducted a survey on the demand of our potential customers. First of all, foremost, the results indicate that we need to secure the safety and reliability of the drone systems to be used for drone delivery services. Secondly, we are required to boost operational convenience of drone systems so users can operate them far more easily. Thirdly, to guarantee the economic feasibility of the drone delivery systems, we need to develop drones that can service multiple points continuously with the payload of around 10 kilograms within a radius of 10 kilometers. A drone delivery system consists of both hardware and software. The former include a drone frame, a drone vehicle, and drone takeoff and landing equipment, whereas the latter include programs designed for real-time drone control, drone operations management, data link between drones and ground control centers, and connection with the logistics information system. Major drone delivery technologies include the automatic flight technology, ensuring faultless flight through pre-specified routes, and the precision automated landing technologies based on the GPS and marker-based image recognition features without the intervention of remote ground control. Critical technologies also include the collision avoidance system that collect information on the speed, position, angle, and acceleration of the object ahead and provide it to the ground control computer systems and the first diagnosis system that detect abnormal situations and quickly respond to the failures through the self-diagnosis of main parts such as battery. Also essential is control technology that keeps tracking the operational status and response to any issues in real time. Sensor technologies are critical too, which vary depending on the specific mission of the drones. Next, I'd like to introduce you to major overseas drone delivery service available now or in the near future. DHL Germany has obtained the government permission and succeeded in delivering product by medical drone for the first time in the world. The company has since upgraded their drones and is engaged in demonstration project to fully automate their drone delivery service even amid inclement weather. In 2019, DHL joined forces with EHang, an aerial vehicle manufacturer, to launch drone delivery service in China. Amazon in the USA developed the first commercial drone in 2013 with the goal of providing a delivery service within 30 minutes of placing an order. In 2015, Amazon launched Prime Now, a 1-hour express delivery service. In December 2016, we succeeded in the trial of Amazon Prime Air delivery service in the UK by delivering package up to 2.3 kilograms in weight by drone for the first time in the world. Following Wing and UPS, Amazon obtained approval for its commercial drone operations from the FAA in August 2020 and is now preparing for full-scale drone delivery service. Now let's look at what's going on in drone delivery service in Korea. In 2020, Doosan Mobility Innovation conducted drone delivery demonstration in Jeju province as part of the drone demonstration city construction project. In September of the year, the company succeeded in demonstrating drone delivery of first aid kit in Halla Mountain. After developing a drone delivery service model using its numerous gas stations across the country as delivery basis. GS Caltex is implementing a demonstration project at the moment. After conducting the drone delivery demonstration based on the GS gas station in June 2020 in collaboration with the Ministry of Industry and ETRI, the company demonstrated an Untact delivery service that combines the advantage of drone and robot in October 2020. Since 2019, ETRI has been carrying out the research project commissioned by the Ministry of Trade, Industry and Energy entitled the Research Project on the Construction and Commercialization of a Drone Logistics Service Platform for Rural Korea. The project is aimed at building and commercializing a drone logistics service platform that can guarantee both safety and reliability with the success rate of 98% or more in vulnerable areas in terms of logistics service. Let me sum up major progress in the project. First, we have developed drone boosting 10 kilogram payload and a 5 kilogram battery that can fly up to 20 kilometers at a time to meet various service needs. The demonstration of the product is underway. We have also rolled out and are demonstrating a drone equipped with a hydrogen fuel cell capable of making 30 kilometer flight at a time. We have also developed loading boxes tailored for multi-point continuous autonomous delivery operations as well as customized communication security modules for the purpose. On-board tests are in progress. We have developed intelligent control technologies to control multiple drones in real time too. Trial is going on at the moment. The new technologies include communication modules for simultaneous control of 10 drones, waypoint creation and route management technology, delivery schedule and arrival sequence control technology, and obstacle type identification and response technology. In drone delivery service, the most important thing is technology is ensuring the safety control of drones. We are currently developing emergency failure response technologies, self-diagnosis and failure prediction technologies, high-precision landing technologies, and collision avoidance algorithms. We are developing an operation management system required to actually provide drone delivery services. It will include a centralized operation management system for drone delivery services such as drone operation record, drone terminals, drone delivery route, and environmental information, as well as big data analysis platform customized for the analysis of empirical TV data. ETRI is also working hard to develop a drone docking station for vehicles and unmanned delivery boxes so that workplaces can operate drone delivery service on their own. We are in the verification station for the establishment and commercialization of a drone delivery service that can operate nationwide too. We continue to discover various new drone delivery business model and conduct their demonstration project in the field. The business models include the delivery of ordinary mail in island and mountainous area, the delivery of daily necessities in the event of disaster in island and mountainous area, for which logistics service have become even more challenging. The frequently required transport of suppliers to ship at sea, and the delivery in urban area. We are validating the feasibility of these business models in the field step by step. We predict that in the near future, a service will be operated in which drones deliver goods to the roof of office buildings or the gate to apartment complexes where robots take over and deliver the items to customers' office or houses. To the end, ETRI is developing and applying various technologies such as drone delivery technology tailored for the transport of heavy goods and autonomous indoor and outdoor robot-based delivery technologies. Next, I would like to touch on the expected effects briefly. Drone delivery is expected to reduce delivery time and cost dramatically when applied to island and mountainous areas marked by high transportation costs for a smaller quantity of goods to be delivered. Drone delivery can improve the quality of service to the public for the underprivileged in terms of logistics services, in particular by delivering urgent medicines and daily necessities in a timely manner. Finally, I'd like to add just a few words about our implementation schedule. By 2022, we will upgrade our existing drone delivery systems and complete pilot operations for the new versions for island and mountainous areas. In 2023, we will stabilize the operations of our new drone delivery systems and at the same time expand our operation of drone delivery service across the country. For urban areas, we will finish developing customized drone delivery systems by 2024, and we will start offering quality drone delivery service for any part of the country in 2025. This concludes my presentation. Thank you for your attention.
Welcome back again to this ETRI special session. Now I would like to introduce the third speaker to this session. Digital twin is a kind of digital representation of physical objects, processes, and services used in a lot of different applications. This presentation introduces one of the examples for the digital twin applications. We call this as disaster lifecycle management technology for underground infrastructure. Dr. Mi-Suk Lee at ETRI will explain you the digital twin-based integrated platform for disaster management by using disaster spread modeling and simulation, 3D spatial modeling, intelligent multi-sensor, and AI. She will show you future services including preemptive actions in response to disasters at underground utility tunnels and social infrastructure disaster lifecycle management, and so on. I would also like to invite you to this presentation. Thank you.
I'm Mi-Suk Lee from ETRI. The title of my presentation is Digital Twin-Based Disaster Lifecycle Management Technology for Underground Infrastructure. In this session, I'm going to introduce our project on development of digital twin-based integrated platform for disaster management of underground utility tunnel. I'd like to start my presentation with the three keywords in the title: underground infrastructure, disaster lifecycle management, and digital twin. Typically, the underground infrastructure includes subway, underground utility tunnel, and so on. They are essential to providing social services, especially in urban areas. In particular, there are electric power lines, communication lines, water pipes, etc. inside the underground utility tunnel, and it is usually located under the driveways, and the number of UUT is increasing with the urbanization. UUT are very important facility that supports citizens to keep their daily lives, but it is difficult to maintain and manage it. And also, it is weak in disaster resistance because different types of line are in one underground tunnel. Left figure shows an example of internal structure of a UUT, and the right is a picture of an actual UUT in Korea. If the lines inside the UUT are damaged by a disaster, such as an earthquake, flood, or fire, it may disrupt social infrastructure services. UUT provide the critical services we rely on, but often take for granted until they are disrupted. It doesn't take a long time to feel the effect of not having water for drinking and cleaning, light to see. In 2018, a fire broke out in an underground network cable center in Seoul. Wired and wireless telephones were out of service, and security and medical facilities, as well as all services requiring communication, such as cars and ATMs, were blocked. After that, disaster management of underground infrastructure became a big issue. This figure shows 6-page disaster management cycle. Typically, this cycle consists of 4 pages: prevention, preparedness, response, and recovery. More recently, it is also managed in 6 pages by adding prediction at the front and investigation and analysis at the end of the cycle. 3 pages in the light green box carry out before disaster strike, and the 3 pages in the yellow box take after the disaster. Our project covers the whole page except recovery, not just a certain one page. Wikipedia explains a digital twin as a virtual representation that serves as the real-time digital counterpart of a physical object or process. The concept of digital twin was presented by Dr. Michael Greaves in a presentation on product lifecycle management in 2003. I think the big advantage of a digital twin is that it can simulate in the virtual world certain experiments that are difficult to carry out in the real world. These days, it is widely applied in many areas such as manufacture, city, medical, energy, and more. Here are some examples of digital twin in Korea. First is an example of designing a car. Second is a virtual Seoul. Third is a traffic congestion prediction. And the fourth is a wind power efficiency and failure prediction. With these 3 keywords, we have been started a project to develop a digital twin-based integrated platform for disaster management of UUT last year. The goal of our project is to develop a disaster management platform for UUT so that all citizens to keep their daily lives without interruption. This project is jointly funded by 4 Korean ministries and total 21 research institutes, universities, and companies are involved in. This figure shows overall scope of our project and the role of 4 ministries. We focus on 2 main services in our project. First service is for a normal situation. In this case, it manages the UUT and collects data by manned and unmanned patrols. The risk inference algorithm is going to be developed using the collected data. Second service is for an abnormal situation. To deal this case, we are developing premonitory sign detection and decision support algorithm for the first and active response. For this project, MOTIE support the development of an intelligent multi-sensor and guided evacuation lightning technology. MOIS support the development of integrated disaster management services. MSIT support development of a risk inference and decision support algorithm. And MOLT support the developing of a 3D geospace construction of UUT and detection of flame, smoke, and abnormal movement. Let's watch our service scenario. First, patrol and inspection using AR terminal. Intelligent patrol and first response. This is a monitoring center. Automatic reporting to relevant authority. Light control for evacuation and guidance. This figure shows the overview of our disaster management platform. First, various data are collected from fixed multi-sensor module, low-light CCTV, and rail robot, and so on. Rail robot patrol inside the UUT on a schedule and collect data from various sensors. The collected data are transmitted to the digital twin-based disaster management platform. In the platform, the collected data map into 3D geospace to generate GeoIoT information. Decision support information is derived by analyzing this GeoIoT data using big data analysis, artificial intelligence, and modern simulation technology. The operating system receives all information from the platform and sensors and provide a situation control, facility monitoring and control, ranges safety check, on-site response service. We are using AI technology in flame detection and abnormal condition detection. In the next slide, I'm going to briefly explain them. It shows how to detect a flame using information obtained by a robot. The robot moves on the rail on the ceiling. It collects data from various sensors attached to the rail robot, low-light cameras, and thermal imaging cameras. And the flame or fire is detected in real time by using the low-light image analysis and the temperature information obtained from the thermal imaging camera. We are using CNN and DNN for low-light image analysis. We will expand this algorithm to detecting a flood in the future. Previous slide showed the flame detection process using the image captured by a robot. This slide is about how to detect flames in image captured by a fixed low-light CCTV. Normally, the lights inside the UUT are turned off, so it needs a network model that can detect the flame, especially in a dark environment. To deal it, we added an inception block with bottleneck and a speed connection of ResNet to LoNet, and added a filter block at the end of the network to obtain a bounding box of flame. It shows a loss curve and a precision recall curve. The number on the figure mean the probability of a flame or fire. As you can see, the test results show good performance. This slide shows the process of determining a threshold value that used to classify abnormal from normal data. Left bottom figure shows the training performance, and the right bottom figure shows the abnormal data detection performance. We are currently testing with temperature and humidity data, but we plan to expand the experiment to other sensor data such as CO2 and O2 and so on. This figure shows what technologies we are developing at each step of disaster management life cycle to manage the disasters that may occur in the underground utility tunnel. Compared to the disaster management cycle in page 4, we do not cover the recovery phase and added data collection in front of the cycle. I'm going to close my presentation by showing you two video clips for a 3D geospace of UUT we've generated and an AI rail robot in operation inside the UUT. This is the 3D geospace of UUT we built. This video shows an AI rail robot being tested in UUT. The robot running on the rail on the ceiling. The robot can run straight, curved, downhill, or uphill rail. Control center workers can monitor the data collected by the robot in real time. Thank you for your attention.
Welcome back. Now I would like to invite our fourth speaker to this ETRI special session. AI empowers early fire detection technology, which help us detect remote flame and smoke immediately using the real-time video data from CCTV or drone cameras. In this presentation, we will show that how spatial and temporal video analysis enables accurate wildfire detection and false alarm reduction. Dr. Keonu Kim, a project leader at ETRI, has been embarked in research projects on AI-based CCTV technologies. He will explain the benefits of AI, which can be applied to city fire early detection for smart cities and early wildfire detection covering a global area at a low cost with high accuracy. Please enjoy his presentation. Thank you.
Hello, everyone. Let me introduce myself. My name is Keonu Kim from Korea. Our members of Authentication and Recognition Research Section have been researching various artificial intelligence technology for video analysis and privacy protection during the last 20 years. Especially, identification and tracking are our main concerns. In this talk, the artificial intelligence technology for early fire detection we are developing will be discussed. As you know, a lot of research on the fire detections are ongoing in many countries and in some applications, but the performance is known to be not sufficient. So, in this presentation, I'm going to talk about our research and highlight the difference from other technologies. Before we talk about the technology, I would like to present a trend of the wildfire outbreak. This slide shows the number of the fires and lost areas since 2011. Though Korea is not so big country, 70% of country is mountainous. Wildfire losses in Korea is increasing year after year. Especially such trend is accelerating since 2017. According to the European Space Agency, fire affects 4 million square kilometers of Earthland each year. It corresponds to about half the size of the United States, larger than India, or roughly 4 times the size of Nigeria. At least 470 wildfire disasters, including only incidents that claimed 10 or more deaths or affected over 100 people, have been reported globally since 1911, causing at least $120 billion in damages. And scientists have warned wildfires are becoming more frequent and more widespread due to the increase in temperature. Actually, the prevention of the wildfire is not our interest because CCTV-centric video systems are mainly focusing on the already broken out situation. So our concern is how we can reduce wildfire damages using CCTVs and related video systems. I think the most effective way of damage reduction is early extinguishing of wildfire, and early detection is mandatory for that. Consequently, the early detection of wildfire is the key enabling of early extinguishing. There are several ways of monitoring wildfire outbreak. Traditionally, wildfires are generally watched by people's bare eyes from the watchtower, generally located on the mountain's peak. Such watchtower monitoring requires a lot of cost because many people's effort should be involved. The introduction of a network-connected optical camera enables efficient monitoring. A person can watch multiple cameras at the same time, panning and zooming on the camera, leading to the precise monitoring. And the camera with the optical zoom can easily see smoke with a few minutes, broken out more than dozens of kilometers away. However, such job requires people to constantly and diligently stare at the boring live video. Humans are difficult to maintain attention when performing monotonous work. Such a monotonous work is better adequate for computerized program, continuously keeping sensitivity. The computerized detector might produce some false alarm either. Such an alarm must be handled by people. There are many ways to detect a fire outbreak. Electronic sensing devices can detect heat, smoke, flames, and gas. The sensing devices can have solid performance, but cover narrow range. In order to cover wide range, high cost is required. Images captured from satellite or UAV, a manned aerial vehicle, can be also used to detect wildfire. Currently, the aerial image is not appropriate for early fire detection because of the low temporal and spatial resolution. Nevertheless, there is a growing appreciation for the potential value of satellite to aid early fire detection. Image from CCTV or drone is also useful to detect the fires in the early stage, enabling real-time watching, high spatial resolution, and wider area coverage. There are commercial products like Forest Watch, Fire Watch, Smoke D, wide range detection systems inside the FD. Some products were applied to the real world more than 10 years ago, CAL FIRE and some other local fire agencies in California have deployed at least one computerized smoke detection systems. But some deployments were reported not satisfactory because the systems were plagued by high false detection rates. In 2012, Alberta reported the evaluation producing initial false positive rate of more than 300 per day, which was reduced to from 10 to 30 per day after fine-tuning camera setting. Image-based deep learning technology for fire detection is currently popular in many research. Pre-trained open models are used for fire detection. We have developed the image-based fire detection system based on the EfficientNet models. The system is designed to classify whole images into 3 classes: flame, smoke, and others. The most important and hardest work is building the dataset having sufficiently enough fire images. In the image repository on the web, just a couple of 100 images about wildfire can be collected. Even more data augmentation is used for more data acquisition. As I mentioned at the previous slide, our concern is early fire detection. Actually, you can find tremendous images by just searching by keyword fire. So how we can build early fire dataset for artificial intelligence learning is our main issue. This slide shows the result of our fire detection systems. This video was from the Gwanang Mountain Fire Watchtower in Seoul, which was broken out in 2017. As we can see in this video, the camera is automatically rotating, found the wildfire at initial stage. It seems to be very clear and good, showing excellent performance. However, since there are so many noises similar to the fire in the real world, it may be very difficult to get precise results like this example. In this video, upward smoke is well detected, but rightward smoke is not detected, and some clouds are identified as smoke. Actually, good detection suffers from the unknown, that is not trained, images and confusing images. Since we are likely to collect upward fire images, the most datasets have upward direction, but rare downward and sideward direction. The model trained with such an unbalanced dataset makes the performance of detection decreased. Most of the cloud images include features easily confused with smoke. Such a fake feature is likely to produce false alarm. Image-based wildfire recognition considers only a spatial constraint, like shape of solid object. But the fire has motion feature, not solid shape. Therefore, video recognition is supposed to be a candidate for fire detection recently. It considers temporal constraint either. We have also developed a video-based fire detection system. Slow-past model and X3D models are evaluated for this system. Though these models are originally designed for people motion, it turned out to be good for the fire detection. For performance, tons of fire videos are required for training, but it's very hard to gather because the fire outbreak is not common. All kinds of fire videos with flames and smoke features have to be collected. They include not only wildfire, but also city fire, bonfire, candle fire, and so on. In order to solve the problem on regular wildfire dataset for training, we started making virtual training data. The simulation is one of the good solutions for collecting lots of various fire scenarios. By simulating smoke and flames particles, virtual fires can be easily generated to satisfy users' taste. The virtual wildfire can be generated by 3D modeling tools. With such tools, Sideward and downward fire can be simulated, even more various sizes and colors. We found that the performance is enhanced by 5 to 10%. This slide is the result of video-based fire detection. At each tile, the color represents result. In this result, smoke is well detected, but that of background is not satisfactory. The bad result is supposed to come from camera movement and lack of proper environment video data. These artifacts can be filtered by exception of camera movement and suppressed by retraining with additional local environment video data. This slide shows another result. Each smoke and flames of the wildfire is detected and tracked well along the camera movement. Our system can detect fire in the wild area and even city area. In this video, this guy tries to make a fire. At the initial stage of the fire, a small and intermittent flames is well detected, and thanks to the huge amount of CCTV footage, pulse noises at the environment are suppressed. Flames and smoke from the fire on the car is well detected in this video. With the image-based fire detection system, the flickering light of passing vehicles are also identified as a flame, but with video-based system, the light of passing vehicles are well excluded. Our video-based fire detection system is under development to train more video data. The dataset version 1 includes totally more than 25,000 video samples. About 1,700 flames and 3,200 smoke data was included. The F1 score on flame is 47.5% and that of smoke is 26.8%. The dataset version 2 has more video data than version 1. The dataset version 2 includes totally about 57,000 video samples. The number of flames and smoke video data is several times higher than before. The F1 score of flame and smoke was significantly higher than before. Thank you for listening.
Welcome back again. Now I'd like to introduce the last speaker to this ETRI special session. Meet DeepView, a visual big data discovery platform to analyze large-scale image and video data in real time. In this presentation, Dr. Yusuf Bey, who leads the DeepView project at ETRI, will introduce DeepView's two video surveillance applications using CCTV. First one is detecting people illegally dumping garbage, and second one is detecting people who are drunk or fallen. The first application can make cities cleaner, while the second application can make cities safer by statistically analyzing when and where people dump garbage and get drunk or fallen, respectively. The title of his presentation is Making the City Cleaner and Safer with AI-based Video Surveillance. Please enjoy his presentation. Thank you.
Hello everyone, my name is Yusuf Bey and I'm leading the DeepView research project in ETRI. DeepView aims to develop an AI-based visual discovery platform that analyzes large-scale image and video data. Today, the topic of my presentation is making a city cleaner and safer with an AI-based video surveillance. I'd like to start by looking at the instruction video.
We are living in the era of AI. Computer vision is one of the fastest developing technology, and it has begun to change our real-world life. It is widely used in various domains such as video surveillance, medical image analysis, self-driving car, etc. ETRI is performing the Deep View project to develop a visual discovery platform using AI-based computer vision technology that analyzes large-scale visual data such as images and videos. ETRI has published its excellent results of the Deep View project in numerous AI-related top-tier conference papers and SCIE journals, and is developing practical applications. Recently, the installation of surveillance cameras in the public sector increases fast as it has proven its usefulness in monitoring traffic, natural disaster, fire, and crime. However, as the manpower for monitoring these surveillance cameras is still limited, many unusual events captured by the cameras are often missed. Therefore, ETRI has developed AI-based video surveillance technology to respond to these unusual events effectively. In the Deep View project, the world-class object detection and action recognition technology has been developed capable of understanding events with high speed and accuracy. ETRI introduces two public social problems that has tackled by using the technology of Deep View. The first target problem is the illegal garbage dumping issue that degenerates sanitation and aesthetics of the city. Many cities have manual reporting system for illegal trash dumpers and simple sensor systems to prevent illegal garbage dumping. However, these systems rely on human resources and suffer from a high false alarm rate, which leads to ineffectiveness. Therefore, to provide effective solution to local governments in Republic of Korea, ETRI has developed a trustworthy illegal garbage dumping detection system. This system uses the effective object and action recognition technology and makes the best use of the surveillance cameras that are already installed in the city. Traditional intelligent visual surveillance systems require a lot of effort to set camera configuration manually. In addition, illegal dumping cannot be accurately judged because it is conducted in a simple rule-based method rather than a learning-based method. To tackle the problem, ETRI has developed AI-based dumping detection technology that works well without manual configuration using the learning-based method. Moreover, it is highly effective in preventing illegal dumping because the technology can detect dumping events in real time. With the dumping detection technology, local governments can collect information about when and where dumping is frequent and use this data to develop policies to make cities cleaner. Therefore, it goes beyond simply monitoring illegal dumping, and it can contribute to the creation of a clean urban environment. The second problem that ETRI tackles is the safety issue in the city. Among various dangerous situations, ETRI focuses on detecting a person who may be in danger from falling down due to illness or a person who is blind drunk. A person's falling down can be a signal of being endangered. One who falls due to an illness should be treated in the right time, and one who falls down due to being drunken can be targeted by crimes such as theft. As mentioned before, it is almost impossible to monitor the whole cameras manually due to the limited manpower. To deal with the problem, ETRI developed the technology to detect a person who is endangered with visual artificial intelligence technology. The conventional object and human detectors that are widely used can recognize people who are in upright poses such as standing or walking quite well, but they usually fail on detecting people with unusual poses such as lying down. Therefore, ETRI developed a human detector that is robust to the change of human poses through multitask learning. It classifies humans into 6 kinds of posture states, and their joints are estimated concurrently while the detection performs. As a result, it can automatically detect humans with unusual postures, as well as humans with common upright postures. Through this technology, the control center can monitor whether people are endangered and help them in the proper time. Consequently, it can contribute to saving lives and preventing crime. Advanced visual intelligence technology can provide insight by accumulating data by time and location based on dangerous situations occurring in the city. This data can be utilized for predicting the possibility of events and preventing accidents through automated contact with police offices or fire stations about an emergency. It can accelerate the whole rescue process and contribute to the safety of citizens.
As mentioned in the previous video, ETRI is working on the DeepView project. DeepView is an AI-based visual discovery platform that analyzes large-scale visual data. It especially focuses on the visual understanding of various objects and human actions based on the visual big data platform. We introduced two examples of how DeepView has tackled public social problems with an AI-based video surveillance. The first social problem we tackled is the illegal garbage dumping detection. Illegal garbage dumping is one of the most prevailing social problems in every city. It not only occurs environmental and sanitation problems, but also causes a lot of social costs. To prevent illegal garbage dumping, it is very important to detect and notify dumping events in real time. However, there are some technical challenges. Firstly, as people dump their garbage in various ways, it is hard to define dumping action and make machine to train it. In machine learning, patterns with high variance is hard to be trained, and therefore, it is hard to train dumping action. Secondly, garbage usually appears in small objects in images. Conventional detectors detect large objects well, but they have limited performance on detecting small ones, so garbage is usually missed. Thirdly, since garbage has various shapes such as plastic bags and boxes, it is hard to define how garbage looks like and make the machine to train it. Lastly, it is hard to develop the system to work robustly about various camera angles because action patterns appear in different forms depending on the locations and viewpoints of installed surveillance cameras. To deal with such challenges, we designed our architecture in two phases as shown. Firstly, dumping detection detects dumping events through the relation between human and human-held objects. Secondly, dumping verification removes false alarms like shadows. I will explain them in next slide. So let's start with dumping detection phase. At the early part of this phase, we want to detect and track human-held objects around hand. To this, we use joint estimation and joint heat map to find the candidate region near hand, and refine the candidate region by comparing the foreground and heat map to detect the human-held object. Finally, we detect dumping action through the relation model between human and human-held objects. Especially, we interpret the relation using graph convolutional neural network. Consider a special temporal graph of human pose and object-related human pose. This is the detection results of dumping actions. In the figure, when garbage dumping occurs, red messages are displayed, and the bottom two figures show normal cases. Left is not carrying an object. Right is just carrying an object, not dumping. However, sometimes dumping detection phase is not enough. Figure at the upper right shows an example of false positive due to a shadow. We tackle such a problem by adding verification network that understands human action more precisely. So we trained the verification network using multitask learning with a combination of various data sets. Here, the network trained human pose, course action, and fine action along with target dumping action. As the result, with the synergy of human understanding, network can detect dumping action better. This is the result of garbage dumping detection. Firstly, it detects human-held objects. Secondly, it initially detects dumping action through the relation between human and human-held objects. Thirdly, it estimates dumping action using a special temporal graph of human pose and object-related human pose. Finally, it verifies dumping action via multiple actions, including course, find, and target action through multitask learning. The second social problem we tackled is the fallen human detection. Fallen humans can be a sign of being endangered due to illness or being drunken, but sometimes they are not rescued at the right time because the monitoring manpower is limited. So there were attempts to use AI on the monitoring, but there are some technical challenges. First, conventional human detector heavily depends on human pose. They only work well on humans with an upright pose. Moreover, most of conventional pose estimators detect human pose after detecting human. This makes the whole process of human pose estimation slow. So to train a network for understanding unusual human poses, we established a new human pose dataset. We defined 6 kinds of human postures, including crouching and lying. The dataset consists of 93,000 human objects with instance segmentation, key points, and posture annotations. We introduced a human state estimation network, HSENet, for our human pose dataset. In particular, to make our detector faster, we designed HSENet New, which can detect human and predict pose at the same time. To test the effectiveness, we also built the counterpart model, HSENet P, which predicts posture after human detection. In our test environment, it is shown that HSENet New is more efficient in terms of computation. Next, we compared the accuracy of 2 networks through an evaluation study. It shows that HSENet New is more accurate compared to HSENet P. Therefore, we used HSENet New as our final fallen human detector. These are the qualitative results. Inspecting the result, the conventional key point detector constantly misses people who are lying on the street, while our human detector successfully finds them well. We also show another result of our fallen human detector on the streets. Regardless of poses of the people in images, it detects them with consistent performance. In conclusion, we introduced 2 applications of DeepView to make a better city with an AI-based video surveillance. First, illegal garbage dumping detection will contribute to making a cleaner city by reducing environmental and sanitation problems. Second, fallen human detection will help to making a safer city by rescuing endangered people in the right time. In future works, we'll extend our research to detect more various accidents in cities and hope that it can contribute to making the city better. Thank you very much for your kind attention.
율동으로 가자.
한 개의 목적지가 설정되었습니다.
An autonomous vehicle that doesn't have a driver's seat has been developed and is given a boost to the era of fully automated driving. The existing commercialized autonomous vehicles are level 2 or 3 self-driving cars which have a driver's steering wheel or need human intervention. This week on NavTube, we introduce a leading developer of future mobility platforms.